the psi of x.
That can't go. It can't. It comes along for the ride. It comes along for the ride. It doesn't go away when you take it.
Okay, so what happens when you add this on this function?
Just get like side x and the GT drops out.
The GT drops out.
It doesn't go above. It comes along for the ride.
It's 0?
Product rule.
Okay, so you use the product rule.
Comes off the
Okay,
ride.
guys, if you can't see this, go and do every step yourself, okay?
You're going to end up with the second derivative of the psi function. The psi has the, I'm just going to go to 0 because it's time independent.
Alright,
Sorry.
so partial squared with respect to x squared of g times psi, I'm only going to write it like that, equals partial with respect to x, over partial with respect to x, and g of psi. I'm only going to do this a little bit here. This equals partial with respect to x. If you want to use the partial rule, it would be partial g with respect to x times psi, plus g times the partial psi with respect to x. What is the partial of g with respect to x? 0. Okay, so that goes away. So this comes out to be g times the partial with respect to x. So then you take the partial with respect to x of g, the partial psi with respect to x. That equals the partial of g with respect to x times the partial psi with respect to x. Right? Product rule. Plus g times the partial squared psi with respect to x squared. What is the partial of g with respect to x? 0. So what does this term come out to equal? G partial better be partial squared psi with respect to x squared. So guys, I didn't have to remind you guys that, all right? Okay, Matt? Yeah? I guess I did have to remind you that. How many people are comfortable with that?
That, yeah.
Okay, so what that is just remembering what, these things really are. How many people have had math physics?
I just couldn't wrap that out of my head right now.
Okay, but it's, yeah, I mean, it's just important to see that I'm applying the product rule to a function. I'm taking a derivative of two things. So the product rule is you apply it to one thing, the derivative times that thing times that thing, plus this thing times the derivative of that thing. Now this thing, it doesn't have any, and so its derivatives go to 0. So essentially this comes out. Okay? So it's harder to do that than it is to know the answer here. Okay, so how am I going to write this?
GT on the outside.
Yeah, so I'll go GT.
Partial square of
Right? Then what?
plus v of that GT minus.
Yeah, okay, now somebody else. What happens over here? Over here, so now we have over here.
It's not good with the product rule, but with partial t, right?
Yeah. Right? What happens to the psi of x? It comes out in front. Right?
Yeah.
Okay, so how would I write
opposite what happened with
Okay, so how would I write t like over here?
Like, you think you're going to do it out, or can you just
No,
like,
just write out the answer.
should it be side, partial squared,
I don't have partial squared, right? Just one.
I was kind of just, okay. I was kind of just looking at, I didn't really have to do it out.
Okay, so use the product, so I'll do that.
IH bar psi of x, partial t, g of t.
That's right. So it's I, H bar, psi, I'm not going to put a vex anymore, it's a little psi, it's just times partial g with respect to t. Okay?
I was just looking because it looked like, oh, right.
Yeah,
That's,
it doesn't look exactly the same, but it's the same technique. right? It's just the first order derivative.
This is just double quick. Yeah, just
Good, good. All right, so guys, what I'd like you to do is, so here's your deal. This is what you should be doing in class. So tonight you go home and in your notes you go, you know, I normally wouldn't show these steps. I just go to here. So then your job would have been to go home and in your notebooks to say, how the hell did I do that? And if you didn't know how I did it so that you can do it yourself, then you would come out in your notebook and do all that stuff. And then if you weren't able to do that stuff, then that's the first question that you'd ask me instead. Okay? How many people are more comfortable now? Okay, there's a slight comfort level increasing. Okay, so then here's the standard thing to do with when you do separation of variables. All right, is you divide everything by you go 1 over g psi.
Just to factor it up.
Yeah, and then watch what happens. All right, so what happens when I divide by g psi for this term?
G comes out. G gets allowed.
Yeah. So let's write it out. It becomes
And you're really saying g of t.
right. I'm no longer going to write g of t. G, I already said is
Alright, sorry.
function times it. Okay, so let's write it out. Minus h bar squared over 2m. Then what?
You do 1 over the side.
I need a 1 over psi. I'll put psi of x in here for the next step.
And then part double or partial squared side.
Yeah, very good. What's my next term?
Plus, would you do this b or would you do
b of x. Yeah.
Yeah.
All right. And that's going to equal
IH dt.
I h over psi
Oh, yeah.
over g?
Over G.
1 over g. Over g of t. The partial of g of t with respect to t. Right?
Yeah.
Which in that, what is that saying? Like,
Okay, so let's look at
as the Hamiltonian is going to 0 as time goes to infinity.
I don't know about that, but all I'm trying to do is solve a mathematical equation right now.
We're saying 1 over g of t. This looks like it.
Okay, so here's what we have a condition of our assumption. Okay, what is all this stuff a function of? This is a function of x. What is this stuff a function of? Time. And what does it have to equal? For our assumption that psi equals g times psi to work, right? Okay, so this is it. Right, so what we're doing is we're finding the conditions for which our assumption, our initial separation of variables assumption works. Okay, so let's look at this stuff. Alvar, you've got it, but let me try to explain it because this is a subtle argument. All right, has anybody taken PDEs or solved this partial differential equation with separation of variables in math or in math physics? Okay. Okay, so here's the big step. Here's the biggest step to solving this. And everybody agrees, this condition has to be true for our assumption to work, right? For our solution, this is what has to be true. Okay. X and t are both what? Dependent or independent variables? What's that? They're independent variables. Okay, so if they're independent, what does that mean?
Linear combinations of functions, those variables are.
One is equivalent from the other.
Okay, you're talking a little bit like linear independence, it sounds like.
Yeah, maybe.
Independent means X can be whatever the hell it wants, and T can be whatever the hell it wants. All right? Everybody got that? So this is the toughest argument here, is the thinking argument. All right, so let's fix X. Let's fix X. And say f of X equals 3. So we have 3 minus f of t equals 0. And t, so let's fix X. Well, leave t variable. All right, so t can be anything it wants, right? Right, t can be anything it wants. But in order for our equation, in order for our assumption to work, what does f of t have to be?
3.
It has to be what?
3.
It has to be 3. All right, so in other words, that these two, what we're saying here is that these two have to be equal to a constant. That this has to be equal to a constant, and this has to be equal to a constant, and the same constant, so that you get this minus this equals 0.
Well, couldn't it just be equal to the same thing that's changing at the same rate?
No, because here's the thing.
Huh?
Because x and t are variable, I
Yeah.
can have it be whatever I want. This is the heart of my argument. Because I'm free to let these variables be whatever I want, I'm going to fix x. I'm going to stop it. Whatever it is.
No,
And then let t vary.
Right, but if both x and t,
Vary the same way.
then that would be
Doesn't
true.
answer the same thing here.
Yeah, that would be an answer.
It would be an answer, but it doesn't take into account this case.
In fact, they're independent variables.
Right, because you're saying, what if one is 3 down and 3 down? What if one is 4 down and 4 down? What if one is 5 down and 5 down? But because they're independent, I'm going to stop this at 3, and then let the other go when it's going 3, 4, 5. It doesn't work. This is the only way that this can work. The only way that this can work is that if f of x equals c equals f of t.
Right.
Equals some constant.
But if it equals c, which equals f of t, then they are changing at the same rate, because even though you're letting t be variable, both have to be equal to the same thing, right?
Mike, I'll let you think about this, all right? That is the answer.
Can I ask something?
And
Aren't you saying that? Can you leave that right side of the board, please?
yes,
Aren't you saying that they have to be the same thing?
I am saying that they have to be the same thing.
So how can t be variable? It can't. It has to be equal to f of x.
I'm saying they have to equal a constant. So here's the scoop.
The t and the
What I'm
x can be
saying-
variable functions.
So what follows from this? So what can I do to solve this?
Constants.
Okay, so f of x has to equal constant, f of t equals a constant. Really? What is f of x? This stuff. What do I set that equal to?
F of t.
A constant. A constant. Right? What do I set f of t equal to?
Same.
Constant.
Can you give an example of a function that changes a variable but it's
No,
constant?
like, go home and you do it. Look, okay? Because I've done that in my book. All right? Yep.
What was the advantage?
Any
What was the
ideas?
advantage of for your assumption you had going on there? What was the advantage of putting it equal to 0? Like, why did you make it 1 minus the other equal 0? When
To try to show this idea that they had to be equal to a constant, equal to the same constant.
oh, okay.
So that's it, just to make the argument more clear.
Exactly. Okay, it's like a cup. Like one's gonna equal the other.
Yeah, exactly.
All right.
This is just to pull up this argument.
All right.
This is a very subtle argument.
Yeah.
Makes your head hurt. So Mike, I agree, this makes your head hurt. All right, so tell me what, go explore, and once you've done that, come back and bring that problem to us. Go explore.
But what you're saying in
Mike, go
class
explore, please.
seems
All right.
contradictory.
It's